in our games.
Hitches? Can't be true.
Oh, they're real, all right.
Oh, yeah, we've seen them.
It's a real struggle.
Sounds like it's time for a hitch hunt.
There's hitches in our game.
Makes our players go insane.
We see all of them, it's true, which we'll note in our review.
We won't take it, everyone. The great Hitch hunt has just begun. Kill the hitch, kill the hitch. Fainters might make you sick. All these hitches, burn them down. No more raindrops in my town. Profile it, trace the pain. Hits engaged on me insane. Scar the logsticks through the code. Find the frames, regain that's load. If we channel all our might, we can get them out of sight. When no stutters will be had, makes the foundry people glad. Now get ready for a fight. We will debug till it's right. Now all of you, kill the hitch, kill the hitch. Optimized and running rich, smooth like butter, keep it slick. Locked at 60, renders quick. Kill the hitch, kill the hitch. When it's dead, commit the fix, and we will not ship at all till we kill the very last hitch. Kill the hitch, kill the hitch, kill the hitch. Hear ye, developers. A great scourge plagues our beloved industry. There are hitches in our games. And I don't know about you, but I'm sick of it. I say we kill them all. But I need your help. By the end of this presentation, all of you will also be hitch hunters. And as hitch hunters, we have but one goal. When I say, what are we gonna do? You all say, kill the hitch. What are we gonna do? Kill the hitch. What are we gonna do? Kill the hitch. Kill the hitch. That is right. But one does not simply just kill the hitch. You need tools of the trade. First, we have the lantern of insights. This is no laughing matter. The lantern of insights allows you to see the hitch. Do not fire blindly into the darkness, for you will often miss. Next, you need the source of truth. It allows you to know why the hitch exists, and it can give clues on how to kill the hitch. Lastly, your weapon of choice. You know where the hitch is. You know why it exists. Now you figure out how to kill it and then go for the kill. The specific weapon and method will differ based on your needs. That was a lot of fun, but let's get real. All of these steps were a metaphor for always using the what, why, and how workflow, the methodology. I have a methodology. I have a whole presentation about it called Maximizing Your Game's Performance in Unreal Engine. If you're watching this online, I actually recommend pausing this video and go and look at and watch this presentation. I consider it a prerequisite for this talk. But for the rest of you, basically to summarize it, first, we always figure out what is slow. We see what is causing the slowdown in a profiler. Because if it is time consuming, it will show up. Next, and only after the first step, we check why it is slow. And here we investigate, go by fact, check the source, don't guess. Ask people, go on Unreal Source, the Discord channel, use Epic Priority Pro Support, or formerly known as UDN. And then, as the last step, how do we fix it? And this is only with all the info we've gotten before. I see a lot of times developers, they see the game is slow. Oh, my game is slow. I'll just start fixing things. I'll optimize my meshes. I'll go turn on random checkboxes. That is not the way we do it. We measure, we investigate, and then we know exactly what is slow and why, and then we tune that. And I wish I could just say this, like, just do this, enter first stage and bye. But still, games are hitching. And I think, well, because figuring out the why can be difficult and sometimes too late. Suboptimal workflows can compound to be hard to fix late in production. Some problems, they will not show on the profiler until it's too late. You've noticed you have death by 1,000 cuts and you're 2 months away from launch and you're like, we would have had to do the game differently. And like now we just have to mitigate. It's very punishing to first do things non-optimally and then have to fix them afterwards. Like if you use the what, why, and how, yeah, you fix them afterwards if you can, but I think it's better that I just tell you what are the most common sources of hitches in Unreal games on the market so that you can make your game properly from the get-go. So that's what this whole presentation is about. It's a list of the most common hitches. There's 7 of them that I managed to cram into this in 1 hour. No time for Q&A, sorry. And how to avoid them. But Ari, how did you figure out what are the most common hitches? Well, I actually interviewed 18 studios and code developers, half of them were code developers, that fix hitches for a living. Actually, I want to know how many people here were part of helping me with this presentation. Can you put your hands up? 1, 2, 3, 4, 5, 6, 7, at least 7 of you. And these are scary hitches. I'm going to show you a hitch. I'll tell you, this is the hitch. And I want you to sound terrified. I want you to just scream in terror. Oh my God! Put your hand in the air like, oh, cover your face. Because you cannot underestimate these hitches. If you're not scared of them, you're underestimating them. And then they can sneak into your games. So we have to do this properly. So the first hitch on my list of hitches, very, very common. And remember, I want you to, as soon as I say, you all go like, oh my God. Are you ready? It is the level streaming hitch. You should be scared. That was the proper reaction. And the funny thing about the level streaming hitch is that this is actually the only hitch that is kind of like, it's a family of hitches. It's like, it's a group of issues. Every single hitch in this presentation can happen during level streaming. So it's kind of like I don't know, it's not a real hitch, but it kind of is. A lot of things happen during level streaming. But there's one thing you can do during level streaming that will like make these hitches worse, and that is using actors for static geometry. You have environmental artists, you have designers, you have level dressers, all of these people, and they want to put down lots of static meshes. So what they do is, of course, they drag them in. What else can they do? They put a table, they put cutlery on the board, they put glasses, they could put a bookcase and books and everything like that. Of course. So they put down lots of static mesh actors. And this can work for small games and levels. If you're working on a small game, small level, and you're watching this and you're like, oh, I'm not supposed to do that, don't worry. It's probably not going to show up on the profile for you. But if you're working on dense, big worlds, or a AAA game that has a lot of this, or an indie game that does have a lot of stuff in it, it's actually horrible. It's horrible for dense and or large worlds. So your outliner should not look like that at one time. So why shouldn't you use static mesh actors? The thing is, actors have overhead to them. You have to load them in memory. The garbage collector needs to scan them. Actors are very versatile and like to do cool stuff with objects at runtime. But many times, you just want to put down a rock. And the only thing that rock is supposed to do is look like a rock. And you load in the level, the rock is there. You load out the level, the rock is gone. They're truly static actors, like true to the word static. They're immutable, dumb, they don't do anything. So you don't really need that versatility. And if you don't need that versatility, you should avoid using actors. So what can you do about this? You should avoid using actors for truly static geometry. Instead, there's plenty of things you can do. You can, for example, use packed level actors. They allow a non-destructive workflow. And by non-destructive, I mean like you can still put in all your static mesh actors, like because it's a fine workflow. And then you put them all in a level instance, and then you kind of export it into one single actor that has static mesh, instant static mesh component for each unique static mesh. This is a bit manual workflow, and you have to be careful not to have the actor be too large so that it spans multiple tiles, or not have it too small that you're still putting down too many of them. But this is usually what we recommend people do first. Then procedural content generation. It automatically creates a single actor per cell with static mesh components. You can still create, like, put all your static mesh actors down, again, convert it to a level, and then you can convert that to like a data asset that the PGT can sample from. And then only one actor per cell with static mesh components for each unique static mesh. Let's say also you're a tech artist or programmer or scripter, and you have tools for like scattering around static meshes in your scene. Those tools should be using instant static meshes, not just static mesh actors. And if you're using landscape and putting foliage on it, like grass, pebbles, flowers, anything like that, we actually have a tool called the foliage tool that will automatically put all the stuff into ISMs. Or even Mass or Niagara, if the use case calls for it. For example, if you have lots of leaves and you want them to move, like, hey, maybe this could be Niagara. Or with Mass, you could have, like, you want to simulate a lot of things, but when it's super far away, you don't even want to show it. You just want to keep it in Mass in simulation. When it comes a little bit closer, you put it into an instant static mesh. And when it comes even closer, you hydrate it to a full actor. And then also with PCG, you can even do the runtime PCG GPU scattering. But that's a lot of things you can do it. But what are we doing about it? Well, we want you to be able to keep using the workflow where you put static mesh actors into the world, but at runtime it doesn't incur the overhead. So we have something called cell transformers, and this is only for world partition maps. What our cell transformer does is that it loops over all actor of each world partition cell. It will do some action on it. It does this both for Pi and for cooked builds, so you can test it. It's not going to break only in cooked builds. It's going to be a nightmare to debug. No, it's going to break equally on both. And you can make your own, but we also provide one that transforms static mesh actors automatically into static meshes. And you can see that's like allow classes and disallow classes, and you can change it to be like your own actors. You have to be a little bit careful with it though, because the static mesh actors will not exist at runtime. They will just be instances instead. So like if you were planning on like referencing them or something like that, that's like, oh, what are you going to do now? This is experimental in 5.5 and also in 5.6 that just came out. But like when it comes to like different experimental levels, like this one is only at like editor and cook time. It's not really that much at runtime, because at runtime it's just an static mesh actor. So when it comes to experimental, some say like, you can experiment with this one. Of course, officially I will say don't shit with this, but unofficially I'll say, but I'm not your mother. We're also just working generally on streaming performance improvements like you saw during the State of Unreal. In 5.6, we introduced many of them. Although they are experimental, we haven't turned them on by default yet. But don't worry, we will turn them on by default once they're ready. So you don't have to go like, oh no, I forgot to turn on something in an update and now my world is slow. No, like as soon as it's ready, it'll be enabled by default. Like for example, async component registration, physics state creation and destruction, and a unified budget for async loading and level streaming. Those used to be like two separate ones, so sometimes they would stack. Now it's one single budget. You can also, of course, play with it, turn it on, see how it works for you, but those are runtime, so like be a little bit more careful with those. We also just introduced the fast geometry streaming plugin. There's a great presentation about that from Richard Malo from Epic Games and Jaroslav Rutsky from CDPR. Called Streaming Improvements from the Witcher 4 Unreal Engine 5 Tech Demo, something like that. You'll find it on yesterday's live stream. So definitely check that one out. It basically, all these actors, it will just not even go to you objects. It will just create structs for them. It's a really good talk. Sorry, they just announced it like yesterday, so I don't have a link to it, but it will be in the written version of the article that is on Games once I have time to put it there. Okay, remember what we're going to do as Hitch Hunters when we know what to do. So we know what to do. What are we going to do? Okay, let's try once more. What are we going to do? The Hitch is dead. Oh, but the lantern sees more. And this is a scary Hitch. So remember to react accordingly. It is the physics Hitch! Ooh, that's a scary one. So the physics Hitch, what's the problem? Content teams not optimizing their meshes for physics, that is the problem. And I think maybe one thing that made this problem even worse, that when we introduced Nanite and we were like, you can put whatever you want into the world and it's going to render beautifully. And we're like, it renders well, but for the physics, it's never worked like that for physics. You always have to be kind of careful of how you author your physics world. And Nanite basically went put everything, every single rock, make it high detailed. And Yeah, we need to like reconsider a little bit the physics side of it. So the problem is if you have a big or complex physics scene, it will slow down physics simulations, it will bloat memory, and it will increase loading times. So if you have also, like for example, the smallest loading unit, incremental loading unit during level streaming is one single component. And if you have an instance static mesh component with a really complicated physics object with like thousands of instances, that's just gonna hitch. So what can you do about it? Well, you need to optimize your physics. Static meshes have both simple and complex physics in Unreal by default. You don't have to do it like that. It's not like a requirement that you have to make both. The simple physics are used for the physics simulations when they collide and stuff like that. And the complex physics are for you when you want to trace against it. And you should use simple physics wherever you can. So if you don't need complex physics, just turn them off. I actually recommend for your projects to set the use simple as complex project-wide setting if you can, and only override it when you need it on a per mesh basis. If you toggle this late in your project, like all the current assets still have the old ones, so you'd have to go through and just create an editor utility bit or something to do that. But yeah, if you can do this, definitely do that. You should prefer in order for the simple physics, spheres. They are the fastest, then capsules, then box, then convex polygons, like with these trash bins in the city demo. Here you can see on the left, the one is good, it's just a capsule, super fast. Then you have the polygons. Even though it looks like it has fewer edges, it's worse. We have to check against every surface. And then the worst is on the right, it just has horrible like physics, like it's just too much and you don't need this really. And I know like as an artist, you might think like sphere is the most performant? That makes no sense. Programmers have been slapping my hands because I keep putting in all these perfect spheres that have, infinite amount of vertices. But the thing is, in physics, we're just using math if we can. And a sphere is just a location and a radius. And figuring out if two spheres are intersecting, you just get the distance between them and subtract the radius of both. And that's it, it's super fast. And actually, there is one even faster shape than all of these, and that is no physics at all. If you have a lot of things in a distance, like, there's like some vista there and the user is never supposed to be able to interact with them, like don't even have physics on that object, just completely remove it. You should also set up proper collision channels. So have the objects only collide or overlap with other objects that are actually relevant to it at the physics level, not when you check for collisions. And I actually recommend you watch this video. It's called Collision Data in Unreal Engine 5, Practical Tips for Managing Collision Settings and Queries. This is a really good talk. This was made by Studio Gobo for their work on Hogwarts Legacy, which shipped on Switch 1, I might say. So definitely check this out. Have everyone in your team that has anything to do with placing anything in your level, or any programmer. So basically anyone that has anything to do with like optimization or content in your game, watch this presentation. You should also disable unnecessary overlaps. Whenever an object moves, it checks for overlaps. And this is for you. This is not for us. We don't need the overlaps. It's like if you want to react to it. If you're not reacting to overlaps, turn them off. There's a per component setting called generate overlap events over there. And you can just turn it off. It is on by default because we don't want people to add a listener and have it not work. But they can get very expensive. So, so that means that, actually, I've seen some studios just go to the primitive components constructor and just turn this to false by default, and then only enable it when they actually need. And like that's an engine modification I would recommend to do. If you need overlaps, maybe you don't need overlaps when the level is being streamed in, so you can skip updating the overlaps during that time. Every non-static object will check for initial overlap when it's being streamed in. And this is often unnecessary. Like you're authoring that level, you know that no object is going to be touching your volume or something like that. So I would recommend just first of all set mobility to static on objects that don't move, and then like we know that they don't move, so we don't need to check for overlaps. Or you can turn off overlaps during streaming. There's this config variable, default update overlaps method during level streaming, and it's by default only update movable. And I would recommend putting it to never update for all the actors, and then only override it if for some levels where you're like, okay, this volume actually does need to check for overlaps when it streams in. Then you can override it like that per actor. You should also optimize your overlaps, again, if you need them. If you need overlap updates, make sure it only overlaps with the object types that you actually need. For example, instead of overlapping with everything and then in the on-overlap event cast to the player character to see if you overlapped with them, just have it only be able to overlap with the player character. It makes the physics simulation so much easier. Again, watch this video, it's great. You should also reduce the physics scene size. Only load in the meshes that you need. Use 8 slots for the rest. An 8 slot is when you take a lot of actors and you throw them out and you replace them with one big actor that might not even have collisions on it. And with world partition, we already have this kind of working automatically, and you can adjust it with loading radius. Or if you're using the classic level streaming, like sublevels, you should still cut up your levels into units, chunks, to make sure that you can keep your physics scene small. Also, if you're using world partition, be mindful of the amount of persistent objects. Some further optimizations you can do is, for example, using the editor view modes and Chaos Visual Debugger to find issues. How many people here have ever opened the Chaos Visual Debugger? Can I see some hands? So about like 15% of us. I would like this to be way more. This is a new tool. It is amazingly powerful. You can start it right from the editors, like in Tools, Chaos Visual Debugger. And it allows you to record the entire physics representation of your game for like a span of time. And then you can see every single context and query and everything. And your physics representation of the world should be very simple. It should be optimized and not have any like unnecessary thing. Like I should not see every single stone there. It should just be flat. So definitely, like if you see chaos on your profiler, don't go like, chaos is slow. Go check out Chaos Visual Debugger because you might just have way too much physics. You should also use physics proxies. Do you have like a convenience store and there's a box full of fruits there? Or do you have a library and you have a bookcase full of books? Every book should maybe not, like can the player even interact with every single book? Can the player lift those fruits? If not, turn off the collisions for them and replace it with one bigger physics proxy. We just call it physics proxy when you do this. It's not a specific thing called the physics proxy. It's just like this practice is called doing a physics proxy. Also, if you're doing traces and you're noticing you're doing too many of them and they're too slow, then of course you should just make sure you're not doing too many of them. But you can also turn them into asynchronous traces. This is only possible in C++ currently. But what it does is that it delays the result to the next frame. It does the traces during a time where they're actually more optimized. And just remember that I feel like this is a band-aid, just reducing the physics scene size and the complexity, or just doing fewer traces. It will all like make the traces faster and make your game faster. So yeah. But what are we doing about it? There's a lot of things that you can do. What are we doing? Well, we are working on async physics initialization. It moves the physics initialization and destruction off the game thread, so it's all on the worker threads. This is currently in an experimental in 5.5 and 5.6. You can try it out, but don't sit with it. But I'm not your mom. We will enable it by default once it's ready. Until then, you can test it with these. And we don't recommend shipping with this yet, again, but remember, if you have a too large or complex physics scene, it will still be a problem. This will make noticing those harder. Like nowadays, when you have like a horribly optimized physics world, it might show up in the profiler and someone will go like, I need to look into this. Aha, team, we need to optimize. This is gonna, sure, make it not hit. And then the physics scene will grow and bloat and become horribly unoptimized. And you're not gonna see it until everything in physics becomes slow. And then people are gonna come to me and say, Ari, chaos is slow. And I'm like, no, your physics scene sucks. We're also doing general chaos improvements in 5.6. We did better multi-threading. We made it a bit more data-oriented. We did some speed improvements. Sorry, I'm going faster as I have not that much time. And other chaos improvements for future work is that we're just making it even more multi-threaded, improving the task graph utilization. I think I heard someone say that this island partial sleeping is already in 5.6, but yeah, optimizing the sleeping, and also we just keep making chaos faster and better. We didn't just ship it and say like, good enough. No. We know it can be better improving, and we are working on making it better improving. So now that we know what we have to do, what are we gonna do? The Hitch is dead! Oh, but the lantern sees more. And this is a scary Hitch. Remember, the next Hitch is the actor spawning Hitch. It's a scary Hitch. So, what's the problem? Actor spawning, it actually needs to complete the frame it's initialized. And not just the frame, the line of code that you do it. It needs to be ready for the next line where you actually want to use it. And also for Blueprint, you spawn the actor, you need to be able to use it in the next node. This is unlike streamed actors, because they use incremental component registration, so they can take many frames to initialize. We don't have the luxury for instantiating actors. And if you have very expensive actors, like characters, NPCs, they can take many milliseconds to spawn. And if you have many of them, they can hitch. So what can you do about it? Well, you need to simplify the actors you're spawning. Just do less, have fewer components, have them do less work if you can. Also, you should, if that's not enough, you should limit the number of actors you spawn dynamically each frame. When I was doing the interviews, many studios actually said, especially for limited platforms like mobile or Switch 1, they had a limiter where it only does one actor per frame for very complex ones like characters. So definitely check out that. Also, you should delay the initialization of components where you can if it does need to happen, but maybe not immediately. For example, skeletal animations, they can be initialized later off the game thread via the tick animation on skeletal mesh init project setting. Like animations, they usually happen on ticks asynchronously on threads, but when you're spawning it, we assume you need the correct pose in the next line where you're actually going to use it. And if you don't need that, you can just have it do it during the next frame's tick, but it will show like the default pose while that is between that is happening. But usually you're spawning actors off the camera anyways, right? So just hide it for that one frame and then show it, like, yeah. You should also consider pooling actors where it makes sense and where you can. It's quite easy, just like instead of like always creating a new actor and then destroying it, create an actor, and when you're supposed to destroy it, just hide it. And then when you need a new actor, just show it again and like reset it. So what are we doing about it? I have heard many people asking me like, oh, when is Unreal going to implement actor pooling in Unreal Engine? And the thing is, it's a very hard problem to do that fits every single type of actor currently and future actors for every single game type, for every single project type, for every single industry, and every future, all of these. It's a very hard problem. We've looked into it and it's just like, oh, this is a horrible mess. It's so much easier for you to just create a pool per actor that you needed. Oh, for the bullets, yeah, projectiles, I'll make one actor pool. And for this kind of enemy, I'll make one actor pool. It's super simple because you know exactly what you need to initialize and reset every time. So because of that, don't hold your breath for anything from us. Like if anything, like scene graph in like way future is gonna make it a lot easier for us. But you just do it yourself until then. Okay, Hitch Hunters, now that we know what we're gonna do, what are we gonna do? The Hitch is dead! But the lantern sees more. And this is actually a hitch that scares me a lot. And it should scare you too. It is the dreaded PSO compilation hitch! I don't think you grasp the seriousness of the situation. I said, it's the PSO compilation hitch! Yes, be scared. You were only alarmed. So what's the problem? So when DirectX came out and then Vulkan and Metal, they have a new way of dispatching draw calls. The complete pipeline state object is now needed at the time an object needs to render. But this is actually good. This is amazing. This allows great performance and parallelization opportunities. We managed to completely refactor the render hardware interface thread because of this. But the PSOs also need to include the fully compiled shader code. And there's like, for consoles that we know the GPU, we can just do it while we're cooking the game for the user. There you go, it's all ready. But on PC and mobile, there's so many different graphics cards and driver versions and everything like that. We can't compile for all of them. This is going to be terabytes or even more of data that we're shipping to the users. So we have to compile them on the user's device. And this was maybe okay at first when DirectX 12 was introduced, but with how complicated shaders have gotten, shaders now take a while to compile. So do not take forever. You don't want to compile every single permutation of every single shader in your whole project on the user's device. They would just take forever and you would fill the hard drive. So games only compile the possible PSOs the user might actually see. And this is usually compiled during an initial compiling screen. It'll say like, oh, we're compiling shaders. It takes 10 minutes. The user will be like, as long as I don't have to hit during the game. And when you're doing it this way, in Unreal terms, we call this bundling a PSO cache. This is the old way of doing things. But the thing is, figuring out which PSOs the user might see, it's a time-consuming and imperfect process because, like, what do you have to do? You have to play through the game. Look at everything, look at every permutation of everything and pray that you saw everything, because if it doesn't, it's gonna hitch for the user. I mean, it's possible, but like for linear games, easy. For dynamic games, harder. For open worlds, very hard. For procedural games, like roguelikes, oh my God, so difficult. For user-generated content games, impossible. And they will hit if the PSO hasn't been compiled by the time of the draw call. And it's very tedious. It's like you have to, just automating or playing through. So when it happens, when those hitches happen, it's called the shaded compilation stutter. This is what the industry has been talking about. This is why, all these reviewers online are saying, oh, this is horrible, this stutters, everything. It's this. We have a new tech in Unreal called PSO precaching. It is not the same as bundle PSO cache. We have those two technologies working in Unreal. And it was enabled in Unreal 5.3 by default and introduced. And what it does is that instead of you compiling or collecting all the PSOs and compiling them on the user's device, you don't have to do any of that. Just when we're loading in the level or loading in assets, Unreal will just automatically compile all the possible PSOs that object might need, and the loading will just take a little bit longer. It will be all asynchronous, no hitches anymore. Oh, amazing. But what can you do about it? You need to have a PSO compilation strategy. When I first started looking into these PSOs, I was like, oh, I need to add a few slides about this. And I started looking into it, and it's like, it turned into a major rabbit hole. I was like, what is this? Why isn't there more information about this online? And it turned into a month of research. And I was like interviewing companies, like I had a call with NVIDIA and Microsoft. I was like, what are we supposed to do? And I was talking to my rendering director and rendering engineers. And I was like, what are we doing? What's happening? And we actually have an entire hour presentation. It turned into an hour presentation. It's right there. It's called Game Engines and Shader Stuttering Unreal Engine Solution. You can check it out. There's also going to be a link at the text version on art.games. There's also a blog post by the rendering team that this article references. But yeah, to summarize, any game releasing on PC or mobile on the new graphics APIs, you need to have a PSO strategy. It used to be, I'm just going to make a game, and then you ship it. No, now you need to make a game and have a PSO compilation strategy for your game. That's how making games today is. And this hasn't been messaged clearly enough to game developers. I didn't know this until it became a problem. And I work for Epic. It's like, like every negative review, it's like, oh, compilation stutters. And I'm like, why is this? Like PSOs, what the hell is that? Now I'm doing mine to make sure you all are aware of it. So, what are you supposed to do? If you're using Unreal 5.2 or older, then you need to set up a bundled PSO cache for your game, period. It's gonna suck. You have to play through the game, you have to put automated playtests, you have to collect all of them, and it's gonna be tedious, and you're gonna hate yourself, and then if you miss some, then you're gonna have hitches, and people are gonna say, your game is a stuttering mess, and then they're gonna call us our engine stutter engine, and it's not, it's just like, it's a very hard problem. We're trying our best. Stop being so mean to us. We really want your games to perform. And if you don't have a bundle at all, it's going to be a hitching mess. If you are using 5.3, and later though, we have PSO precaching enabled by default. It's not fully effortless though. You do need to have an initial loader screen while compiling the global shaders. Those are the shaders that aren't tied to the lifetime of an object. Like for example, when we're loading in an object, we know, oh, this object has those shaders. But compute shaders and post-process shaders, like we don't, we have to do them at the start. Unreal will automatically kick them off, but you need to have a little bit of an initial loading screen, like, hey, Unreal is still compiling its initial shaders. There's this variable called none pre-compiles remaining. You have to wait until that turns 0. And for Blueprint games, we do have a Blueprint version of this variable available in 5.6. Sorry that didn't come earlier, but it's very easy to expose to blueprints. It's a single line, you can just make a one-line function around it. It's not free though. It's not a silver bullet. We want it to be one, but it's close. It's as close as we can get. It does use CPU cores at runtime to compile, which is not an issue with loading screens. Like if you have a loading screen, the loading screen just takes a little longer. Oh no, just for the first time, by the way, then it's cached. But if you're streaming in levels for the first time you're playing the game, the streaming is going to take a little bit longer, and it's going to saturate the CPU cores, which might compete with other systems that we're also like going wide on, like the animation systems and anything else. You might think, can't I use both? Can't I just, put bundle PSO cache and then have PSO precaching catch the one that it doesn't catch? It doesn't really work like that because PSO precaching, it happens earlier. It happens at the time of loading, and then the bundle PSO cache, we only fetch that when we are dispatching the draw call. So PSO precaching, because we don't know how it's, like for example, how your object is going to be lit. Are we going to use directional light? That has its own PSO for its shadow pass. Are you going to use a point light? Or like any other type of lights? Like they all have their own pass, their own shader, their own PSO. So with PSO precaching, we don't know how your object is going to be lit, so we just compile all of them. But for bundle PSO cache, you know exactly what situations your object, how it's going to be lit. So how it's going to work is that PSO precaching usually compiles like 3 to 5 times more shader permutations than you're actually going to use. And if you also use it with a bundle PSO cache, it will like reduce that by a bit. So instead of being 3 to 5, it will be like 2 to 4 times more. So might not be worth it. You decide. You also need to test it and profile it. Because, when we were doing this, us game developers, we were, oh, DirectX 12, what's that? That's cool. Okay, let me test my game. Oh, it stutters a lot. I wonder why. Let's try it again. It doesn't stutter anymore. It fixed itself. That was the driver caching the PSOs. So no wonder we were missing it. So every time you profile your game, I recommend you should start it with a clear PSO driver cache command line argument. And actually, I hate giving advice like that. It sounds very impractical. So I just made a plugin for this presentation. You're welcome. It's called the PSO Cache Buster plugin. It will automatically clear the PSO cache for all non-editor and non-shipping builds. So even if you accidentally keep it on while shipping, the shipping build will not do it. But test builds will do it. You can edit it to also not happen to test builds. Did I even add a receiver for that? No, it was for the shipping builds. Make a pull request. Anyways. QA should only be testing the game in this way, in my opinion. And also profiling, you should only be profiling this way. And also, if you do have a hitch, like an actual hitch with PSO precaching, that's not supposed to happen, but you turn on validation equals 2, and then it will log the cache misses. So there's a lot of work that you can do. What are we doing about it? Well, we keep working on PSO precaching. It keeps getting improved. It received a lot of updates, and as of 5.5, we've caught all code paths in our own sample projects and Fortnite. There are no PSO hitches there for any of them. We're currently improving role partition H-slot support. I think that was already in 5.6, where there was a couple of frames where H-slots were hidden while we were compiling it, but now we compile them in advance. They're still not stuttering, but now it's even more seamless. And if you are doing something that maybe we didn't catch in our games, but maybe you have, just notify us through like Epic Pro support or on the forums, and notify us so we can fix it. All right, now that we know what we're gonna do, what will we do? The Hitch is dead! Oh, but the lantern sees more. That is a scary hitch. It is the garbage collection hitch! Ooh. So, what's the problem? Garbage collection needs to happen every minute or so to clean up unused U objects in memory. Every minute and also on every hard level change. And when you have too many U objects, the garbage collector can take long enough that it will hitch. So, what can you do about it? You need to reduce the work the garbage collector needs to do. Reduce your U object count. That is advice number 1. Static mesh actors can be a pain point. That's another reason why you should get rid of them. Also, use world partition or level streaming to only load sections around the player so you don't have too many things in memory. If you do notice that the garbage collector is taking too long and you want to figure out why, you can use this command, obj for object list dash count sort. And it will list all your U objects in the log, sorted, grouped by the class, sorted by how many they are. And I often get the question, Arya, how many is too many? Like how many should we strive to have? I usually say like under half a mil is good, like 100,000, 200,000, fine. 3, 4, 5, getting more than that, you should like maybe start reducing them. If you're over like 1 million, 2 million, or even more, oh, you're doing something wrong. But also this advice might not be future-proof. We might make improvements to the garbage collector. We might get better hardware. Many reasons we might have more systems that don't even use this anymore. So just be sure to profile and make sure that, garbage collector, if it's taking 1 millisecond in your frame, great, fine, whatever. 2 milliseconds, maybe we won't do other systems during the frame. 10 milliseconds, maybe we should start looking into it. More than the frame time, you need to reduce your U-object count. If you're creating a lot of short-lived U-objects, consider pooling them. Like for example, if you're creating a new object with a new object function, then instead of creating a new one and then throw it away just for the garbage collector to pick it up and for you to spawn more, instead just reuse it. And also, if a lot of your U-objects that you create like custom, then if they share the same lifetime, consider putting them in a garbage collection cluster. You can also, if the garbage collector is too slow and you're like, I can't do anything about it, maybe consider running it at strategic times, because you can trigger it manually at any time, and they'll give you they will give you it will reset the time. You can get 1 minute again. Are there any loading screens? Are there any fade to blacks? Are there any UI pop-ups or other still screens where the user isn't going to notice it? You can trigger the garbage collector then, and then, okay, we bought ourselves another minute. If you want to go quite hardcore, like for example, if you have a round-based game with small levels, you can run the garbage collector between rounds, but just make sure the U-object spawning count per round is under control. You really need to be sure that you're not spawning too many U-objects. So if it's always fixed, you can just say, don't run a garbage collector, I know what I'm doing, and then at the end of the round, okay, let's get rid of it all. And if you're having it on some device that has limited platform, and it's running out of memory, we will notice it and we'll force run the garbage collector for you. So what are we doing about it? Well, okay, so regarding the reachability analysis, that's the mark and sweep states of the garbage collector. Most of the phases of the garbage collector are already incremental. The reachability analysis is not. If there are too many U-objects, it will just take too long to scan them and they will hitch. So we are working on incremental reachability analysis. And this is highly experimental as of Unreal 5.5. Don't use it, please. Because often I say experimental, but I'm not your mom. Here I'm going to be your mom. Don't use it. Because we only are using it within Epic for single-threaded servers. So it's not multi-thread safe. Like the client is multi-threaded, so it doesn't really work for the client yet. But we do have interest in making it work for the client also. But even if it were working, and even if you're like, hey, I'm going to turn it on, that's still only spreading the work over multiple frames, cutting into your budget every single frame. So your primary fix should still be to just reduce the work the garbage collector needs to do every frame. All right, Hitch Hunters, now that we know, what are we going to do? Hitch is dead! Oh. But the lantern sees more. This is actually one of the scarier hitches because of how long it can get. Be ready, react accordingly. It is the synchronous loading hitch! It's very long. So what's the problem? In Unreal, you can load assets either synchronously or asynchronously, or blocking is what we call it when you do it synchronously. And blocking load, it will stall the game thread until the asset is loading. This is the source of the longest hitches in Unreal. If you ever are playing a game, your own game, and you notice it's hitching for hundreds of milliseconds, maybe up to a second, it is almost certainly this. Not always, but almost certainly. Because it also flushes the asynchronous loading queue, potentially making the hitch so much worse. And why is this happening? Well, asynchronous loading, which is the better one, where you just say, Unreal, load this asset for me, and then tell me when it's ready. And Unreal says, okay, be right back. And you mind your own business, then Unreal comes like, it's ready now. And you're like, It can be more complicated because sometimes in gameplay requires an object right now. Let's say I have a treasure chest, and I have a huge array of soft references, and I need to load one of them and show it to the user, but the user just clicked the test, so I need to show it immediately. Someone who is a junior or maybe a non-programmer might just go with the blocking code because it's more easy. In the next node, in the next line of code, they can immediately start using it and put it in the UI or whatever. Someone who's more experienced might go oh, that chest, I can already decide what the user gets out of that chest when the user is 10 meters away. And then if I then I start loading it, and then when I get close to it, it's probably done loading. If it's not, I'll slow down the claim animation. And once I touch the chest, maybe if it hasn't loaded by then even, I'll show some smoke effects until it's done loading. And the player character will go whoa, until it's done. The thing is, all of this is extra work. So someone might just take a shortcut or might not know any better and then use the blocking loading function. So what can you do about it? Don't do blocking loads. Please don't use it. Don't do them in your game. You should use the async version instead always. And as I was talking to studios, many studios forbid them. They use asset validators to warn about them, or even they just remove them from the engine, the blueprint versions. They're like, you content team, you can't even do it anymore. And I know it sucks to hear someone say like, oh, just write a validator. You don't know how to write a validator for that, so I just made one for you. I put it into my common validators plugin that includes a validator for catching blocking load blueprint nodes, and it's in that. If you feel like you have any good ideas for additional validators, you can put them in or give me a pull request. Also, you just need to teach your team proper asynchronous loading workflows. What are we doing about it though? Well, we are already informing the user. It's called load class asset blocking. And the tooltip says it will hitch. It's like, don't use this function, it will hitch. Don't do it. And then people are doing it. And I'm like, no. But if one of them sneaks through, like we have implemented partial flushing of the async loading queue. So it's less punishing. And it will still flush at least the current asset being loaded, and maybe the next asset, or any other asset that it depends on. We have it at least since 5.5. I didn't check exactly when we put it in, maybe in 5.4. Anyways, it doesn't really matter because you just shouldn't do it. You're like, don't rely on this, just don't do blocking loads. So now that we know what to do, Hitch hunters, what do we do?
Kill Hitch! Huh? Oh!
The Hitch is dead!
Yay!
Oh! The lantern sees more. It sees one more. But this Hitch is probably the scariest of them all, because this Hitch is coming from within the house. It's in your own studio. It is your own blueprint and content Hitch. Excellent. So what's the problem? Hey, you are doing too much. You have too many or too heavy ticks. You're doing too much in begin play. You have too many timers running. You're doing too much in response to events firing. You have too many sequences or too busy sequences. You have too many audio components, too many skeletal components, too many animators. You're doing too much of anything, anywhere. Okay, so what can you do about it? You need to do less. Profile, see what's happening, fake things if you want. Fake as many things as you can. Everything doesn't need to tick every frame, especially far away and hidden things. The user won't notice. It's video games, it's all fake. Lot things, level of detail. For example, use H-lots where you replace all these actors with one simple one. Only keep close things loaded. But the thing is, when I say level of detail, many people think, oh, it's static meshes. No, everything, not just meshes. AI behaviors when they go further away, simplify them. Audio, when it goes further away, remove them. Particles, when they go further away, simplify them or remove them. You should do less so that you can put in more. You can quote me on that. I thought it was clever. And spread things out. Spread out the ticks. Make far hidden objects tick rarer. You should check out the significance manager. It allows you to assign a significance to something, and then you can decide how to react to it. Like, for example, switching to another behavior class, or a lot, or ticking if you're anything. Like, it's all up to you. Begin play calls are actually already incremental for streamed-in levels, and you can customize it with these variables. End play calls are not, but usually people aren't doing much in end play anyways. But if you do need them to be incremental, I'm not going to say that out loud, but there's a very long okay, I'll say it. Level streaming, route actor, end play for remove from world granularity. What are we doing about it? For your stuff? Hey, this one is on you. But we're helping you with Unreal Insights. We're constantly improving it to make it easier for teams to find issues with their content. And recent improvements include the ability to mark regions, take screenshots in both Blueprint and C++, and just better editor usability. Like you can see there, you have the trace button already in Unreal Editor. Anyone can click it, anyone can start a trace, anyone should do it. Now that we know the last Hitch hunters, what are we gonna do?
Kill Hitch!
The last Hitch is dead! Wow! Good job, everyone. Good job. Having said that, there are more types of hitches. Like there's some of them that I couldn't fit in this because I am almost out of time. Are like animation hitches, UI hitches, and cloth chaos physics hitches. Hopefully, those should make the most common hitches a thing of the past for all future games. But also, we do need to have a bit of a reality check before I finish this off. A little bit. No. We need to talk, developers. There are limits in game dev. I've noticed a little bit of trend where we're kind of acting like it's not. Like, sure, we're not making games for the Commodores of yore, but even though the limits are much higher, there are still limits. They never went away. They're much higher. We can do a lot of things, but still there's a limit. And we have to respect those limits. For example, dense environments, they're hard. I remember when Crysis came out. Oh my God, Lost Force, we'd never seen anything like that before. Can your computer run Crysis? Everyone said, because it was so demanding. It was a technical achievement. We are working on technology here at Epic Games constantly to make this easier, but for us, this is a huge problem. You might have seen it, State of Unreal, how much effort we put into this to make this easier. But still, you need to just take into account, like, hey, I can't just tell my team, just make a dense city, just make a dense forest, and think it's not going to be hard work. It's going to be hard work. Crowds, they're hard. They're so hard. I still remember when I played Assassin's Creed Unity. Amazing game. There was this humongous crowd on the square. Each had different animations. They were all different from each other. A technical achievement. They had a DDC talk about how they made that crowd. It's open now for everyone. You should check it out. So, I don't want to see people say, oh, we put 100 metahumans in our game and it's slow. Unreal sucks. No. You were never able to do that. You needed to think about faking things, level of detail, all of these. This is like hard work. And sure, you saw in the Witcher demo that we had a big crowd, but this was a lot of work. And you need to put a lot of work into it also. So don't discount the amount of work that goes into it. Just respect the challenge, this is what I'm saying. I'm not saying don't do it. Don't do it dense environments. Don't not do dense environments. Sorry, don't quote me on that. I wanted to try it. Just, be aware of it. Do go for big crowds. Just be aware of it. A lot of words to say game development is hard. You need to keep performance in mind during the game's production. Also, remember that Unreal supports many different types of projects. And you need to tune it to your game's needs, because not just projects, industries. Fake everything you can. The more you fake, the more you can put into your game. Level of detail, everything you can. The less you do, the more you can put in your game. And remember, you should kill all the hitches, because when you do that, you are a hitch hunter. Congratulations, you have graduated. At the end of this talk, I want to get a graduation selfie with all of you. So I am going to say, hitch hunters, what are we going to do? And you all say, kill the hitch. Let me see if I can catch all of you. Yes, good. All right. Hitch hunters, what are we going to do?
Kill the hitch!
Kill the hitch! Wait. No, sorry, I have other people I want to thank first before you thank me. I want to thank everyone who helped me with this presentation. Please give me a golf clap while I thank them all. Thank you, CI Games, my coworkers at Epic Games, Bloober Team, and Tanglewood Games. Thank you so much, Assemble, Electric Square, Climax Studios, Respawn Entertainment, keep clapping, Double 11, Ninja Theory, and Dreamlove. Thank you so much, Obsidian Entertainment, Flix Interactive, GSE Game World, Studio Gobo, Virtuous Godzilla, and Crow Team. All of these people and more, thank you so much for helping me with this presentation and allowing me to put your picture on my slides. Lastly, thank you. There's one person that I want to thank the most. This person came all the way to Orlando to this talk to watch me rant for an hour about performance, or they're watching this online. It's all of you. Thank you so much for coming and wanting to make the game industry better for all of us, not just game developers. Thank you so much from me as a game developer, but mostly thank you from me as a gamer. You are helping make this game industry so much better. Thank you so much!
Hitch Hunter, Ari, he'll make it stop, won't let your frames drop. Ari, start, roll at your frames.